Hi folks, I'd just like to welcome you all back to the INTEROPen Staff Access Hackathon. My name's Richard Astley and I'm the lead solutions architect for Condatis. I'd just like to talk to you for a little bit about the SSI OIDC Bridge, specifically using the SSI OIDC Bridge to consume verifiable credentials as a relying party. To support the INTEROPen Staff Access Hackathon, Condatis and SiteKit have made some of the tools available in the SiteKit Toolkit. The tools available are the Condatis Staff Passport for issuing verifiable credentials, the Condatis OIDC Bridge service for integrating relying parties, and our OIDC Bridge Management Portal, which relying parties can use to configure the bridge for their specific use cases. The Condatis Staff Passport issue is part of the Condatis Staff Passport product. This product is used to issue and verify staff credentials. The credential consists of a first name, a last name, an email address, a mobile phone number, and a profile picture of the user. What we'll be able to do today is to issue you with your very own credential into your ConnectMe wallet, and we'll hope that you can use this credential to support one of the hackathon use cases. By using this credential in combination with the Condatis OIDC Bridge and a sample relying party application, Condatis have developed a Staff Passport product which allows you to issue and verify staff credentials. I'd just like to walk you through the process that we use the Condatis Staff Passport to issue a credential to you today. So if I sign into our Staff Passport, I want to manage our contacts, and what we'll do is we'll add a new contact. I'll add a new one in for myself just now. So if I enter all the details, first name, last name, mobile phone number, email address, and we'll make up an employee ID for you. Once we've added in all the details, we can generate the contact, and we've got an option here to confirm it. So if I just quickly check a phone number, and once you're happy with that, I'll confirm that. As part of creating a contact, we'll have to create a connection with the user's wallet. We've got two options here. We can either use a QR code which we scan with the wallet, or we can use an SMS text message. For this example, I'm going to use a QR code, but both methods are exactly the same. So once it's generated the QR code, this QR code's got all the information the wallet needs to initialize the connection. I scan that with my wallet and I've got my notification asking if I'm happy that Condatis SSI agent can connect with me. So if I accept that connection, the connection's now created with my wallet, and our site will be updated with the status in a moment. So now that the connection's been created, we can go about issuing a credential. So the new contact that I'd created was here. So Richard Astley 456895756. So if I go in here, part of the process is I have to upload a photograph of myself. So if I go in and choose an image to upload, I have some profile pictures here, and if I upload my profile picture, it will resize this picture for you. So I've uploaded this contact, and now I've got a full contact available to start issuing the credential. So if I select to issue the credential, I'll type in the details I want for my credential. Once I've entered in all the details, I'll preview the credential, and if I'm happy that these details are all okay, I'll issue my credential. Once I've issued that, I'll get a notification showing up on my ConnectMe wallet, and this is asking me to make sure I accept this credential into my wallet. So if I click accept, the credential's now created in my wallet. Once I've got a credential in my wallet, I can either use this with any other system that supports this credential, or as a test I can go in and actually verify my credential using the Staff Passport. So to verify the credential, it's a similar method where it's got to communicate with a user's wallet. So this time I'm going to use the SMS text message. So if I use an SMS text message, and I'll use my telephone number I used before, and if I click send SMS, I should get a text message coming through to my wallet. This text message contains all the information that's needed for the wallet to satisfy the verification request. So if I select the link in my SMS and select that I'm okay to connect to that, once I've created my connection with the wallet, it'll send the proof request to the wallet asking for my information. So I've just received another notification in my Connect Me app, and if I tap to open this, it's asking me for all my details out of my Condatis Staff Passport. So if I'm happy to do that, I'll send the proof request, and the proof details are now being sent from my wallet back into the system and being verified. Now that we've issued a verifiable credential out to the wallet using the Staff Passport, it's time to have a little look at the OIDC Bridge. The OIDC Bridge is an abstraction layer that allows a relying party to communicate in OIDC with a user that has a verifiable credential that they store within their wallet. The OIDC Bridge is configurable to support many different use cases that the relying parties need. The OIDC Bridge can also be personalised by the RP to support their own branding. The OIDC Bridge has an authorise endpoint that a relying party can use to integrate directly with the OIDC server. Or for today's hackathon, we've provided a relying party application that's already integrated. The OIDC Bridge has a management portal that can be used to configure new relying party registration, the RP scope configuration, and the personalisation for a relying party. For the hackathon, Condatis have hosted a version of the management portal on the cloud, and it's available on the HTTPS address OIDC app dev management portal.azurewebsites.net. There's also a documentation portal that's been made available on HTTPS OIDC str documentation.blob.core.windows.net/web/index.html. When you first navigate to the management portal, you've got two options here. You've got the option to log in if you've already registered a relying party, or you can click to register a new relying party. So we'll click and register a new one, and you're asked to set your client name for your relying party. So I'm just going to put it down as Richard's RP. So Richard's relying party, and I'll click on continue. So what's happened here is it's generated a client ID for the relying party, and it's also generated a client secret. We recommend actually copying down these client IDs, and this will be the only time you've shown the client secret. So we recommend copying this down now, or you may find that you can't actually access it. So if you copy your client ID and your client secret, and we've also provided a login link here that you can take a copy of now, and what this login link does is it'll pre-populate your client ID for you if you use this link to come back and log in the future. So once you've copied your details down, we'll just be able to go down here and click on continue. So we've generated our own client ID now here, and we've got the options given to either configure the scopes, we've got personalisation, or we've got a link off to a documentation. So I'll quickly show you a documentation portal now. So if you click off to a documentation, we've got information here about the registration and personalisation. So feel free to take a look through this in your own time, but we've included information on how to set up scopes and what can be personalised within the site. So if we go down, I'll actually show you configuring a set of scopes right now. So if we go in, we've got variable scopes, and then we've got grouped scopes, which will allow you to create a single scope that will then be mapped to a set of verifiable credential attributes. So I'll start off by adding a new scope. So the scopes that we'll want to use for the OIDC side is, let's start off with a given name. So we'll do given name, and this will be the user's first name. So we'll put in a description here, and the attribute from the SSI credential that we want to map this to will actually be the first name. The next option here allows you to add in a regular expression that the bridge will use as a filter to make sure the attribute being returned from the credential matches any regular expression logic that the relying party wants. So one of the scenarios we see here is a relying party maybe wants to restrict a credential's email address down to a specific domain name. So you'll see that example that's shown as the regular expression there. It's going to restrict it down to an email address that ends with condatis.com. The next box we have here is about attribute constraints. Now the attribute constraint is something that will be applied at the wallet end. So when we make a proof request to the wallet, you can specify that it has to be from a specific schema ID. A schema issuer did has to match this. The schema name has to be this. The schema version, issuer did, or the credential definition ID. So this can be used for a relying party to restrict the credential being used to create the presentation based upon these fields. So if I'm happy that I'm just mapping a given name scope to a first name attribute from a wallet, I'll create this scope now. So you'll see it's created my given name scope, and if we go in and I'll add in another scope, and then we'll show you how to group these scopes together. So if I click to add a new scope, and what we're going to use here is the scope that we want to use will be surname, and we'll have this as the user's last name. And the SSI attribute from the credential that we want to map this to is going to be the last name. Now I don't want to specify any regular expression. I'm quite happy that the value of the last name can be anything here, and again I don't want to restrict this down to any specific verifiable credential. So if I'm happy there, I'll click on add new scope, and now that I've got two scopes available, I'll be able to use a group scope function. And what a group scope function does is it allows a relying party to group a set of scopes together and make a request for a single grouped scope. Now the OIDC bridge will take that single grouped scope and treat it as if the relying party had asked for each of the grouped scopes individually, and when it makes the proof request off to the user's wallet, it'll gather all the attributes together. So if I add in a new group scope here, I want to put this down, and I'll use this as the full name. So I'll add this user's full name, and the related scopes we're going to use given name and surname. So if I've selected these, I'll add new group scope, and you'll see that there's a group scope available now. When the relying party makes the OIDC request to the OIDC bridge, they'll be able to ask for the scope full name and expect to be returned back a given name claim and a surname claim. Now that we've configured a couple of scopes, we'll now look at the personalization options available within the OIDC bridge. So if we go back and click on the personalization, you'll see we've got here the client name that we set earlier on, Richard's RP. We've got the client ID and the option to regenerate a secret. The one thing we do need to do is, in the OIDC standard, there's a redirect URI that a relying party sets where the response to the authorization request is going to be returned. You can set this to your own relying party's redirect URI, or if you're using the sample relying party application, you must use the following redirect URI, and that's https:///oidc app dev relyingparty.azureWebsites.net/sign-in-OIDC. Some of the other options that are available are styling and customization. So you can customize the QR code page of the OIDC bridge with your own corporate logo. This logo can be retrieved from anywhere the relying party is hosting that. you simply add in the URI for the logo you want to be swapped out. Again, the CSS is overridable within the QR code page, so you can take a copy of the sample CSS that's available in the documentation portal. You can customize that however you like and then host it from your own hosting. If you add in the URL to the CSS document here, it'll apply those stylings on the QR code page. If you're happy to use the original branding that's provided, then you can leave both these fields blank and you'll get the Condatis logo and the basic styles that we've supplied. At the footer of the page there's also a privacy policy link and a terms of use. Again, a relying party can swap these out for URLs that point to their own privacy policy and their own terms of service. So if you're happy that you've set a redirect URI and you've applied the styling and logos you want, you can simply save this, and when you're using the OIDC Bridge, any of those styling or personalization will be applied to the QR code page. Now that we've configured a relying party within the OIDC Bridge management portal, it's time to have a little look at the actual relying party. So for the hackathon, we've provided a sample relying party that you can add in your client ID and secret and a set of scopes that you want to use for your requests. We've hosted this relying party on the cloud and it's available at https://OIDC app dev relyingparty.azurewebsites.net. The source code for the relying party application is also being distributed through River if you don't want to use our interface and you would like to take this one step further and actually implement your own interface to it. When you first navigate to the relying party, you'll be greeted with the welcome message with a quick prompt making sure that you have registered your relying party and providing a link that you can go and follow if you haven't already created your relying party. So since we've already created a relying party, we'll be able to go in and have a look at actually making a request to the OIDC Bridge. So if we click on the scope request, so you can see here it's asking us for the client ID, the client secret and the scopes that we want to make for the request. So we'll use the client ID that were registered previously on the management portal, and we'll use the client secret that was generated during registration. And what we'll do first is we'll go for one of the single scopes that we actually asked for. So let's try surname first. So I've set my client ID and secret, and the scope I'm interested in is the surname. So if I click on the submit button, there's an OIDC request that gets made off to the bridge. And it's this page that you now see that can be customized and styled based on the relying party. We didn't set any of these values, so we still have the Condatis brand logo on this and the style sheet that was applied, and we haven't got any footer or privacy links, but they would be shown down here and you could redirect off to your own one. So we've got a QR code that's being displayed now, and what we need to do is we need to actually scan this with our wallet. So if I open up my Connect Me app and we'll scan this QR code. So yeah, I'm scanning this QR code and accepting the connection. Once I've accepted the connection, I get the prompt coming up asking me to share the last name. So if I click on my wallet, I'll view that request and I'll send that over. So that's me just agreed from my wallet to share my last name. So what's happening now is the OIDC Bridge has verified that response. It's converted it back to what the relying party was interested in, and that was the surname. And you can see the claims that have been returned back to the relying party contains my surname. So that's a full end-to-end flow you've seen. We've issued a verifiable credential using Condatis Staff Passport. We've configured a relying party to use the OIDC Bridge. We've set the scopes that we're interested in and the verifiable credentials attributes that should be used to satisfy that request, and we've actually made a connection with the client's wallet and asked them to share out that surname. What I'll show now is I'll actually show the grouped scope in action. So we'll go back to scope requests and I'll enter in my client ID and I'll use my client secret again. And this time, instead of using one of the single scopes, I'm going to use a grouped scope full name. So let's submit that query. So again, this has gone off to our OIDC bridge. The OIDC bridge is going to interact with the agent, and it's going to create this request. So again, if I go back to my wallet and I'll open up the QR code scanner, I'll scan the QR code, and I'm waiting on the wallet. I already have a connection, so I don't have to approve the connection, but I do now have the share request coming in asking for the first name and last name. So if I click on view and I'll select send. So what's happening now is, again, this is being released from the wallet. It's going back to the OIDC bridge. It's all being verified there, and now it's had any validation that was set at the management portal executed against it, and it's now returned back the given name and surname back to the relying party. So you can see, by configuring the management portal for any scopes that you want and mapping those to a verifiable credentials attribute, you can configure any proof requests you want, and the OIDC bridge will handle the verification and return back the claims in the name format that you wanted. Okay, so what are some of the benefits of using the OIDC bridge? So we think some of the benefits are really, you get to keep your existing services. A lot of existing services already use OIDC to communicate for authentication, so it lets you easily integrate SSI into an existing service that communicates over OIDC. Because the SSI stack's really been abstracted away from the relying party and all it needs to know is OIDC, it stops you having to integrate many different wallet providers. Currently there's a few different technologies that really compete, so you have to integrate with many different ones, so that this abstracts that all away from you, so you just communicate with one endpoint and it'll expose an option to the user so they can bring their own wallet to your site, and all the complexity of integrating with many different wallets and protocols is all taken care of at the bridge level. And because all of that happens at the bridge level, it gives you a bit of future proofing from the relying party aspect of it, because it's still a new technology, and there's still a lot of advancements and progress being made, so there'll be new wallets coming up, maybe different implementations of how the standards are being used as well. So as a relying party, you don't have to worry about that. It's really, as long as the bridge keeps up to date and it implements any new providers as they come along, it takes a lot of that away from you. I've shown you today how we can use our Condatis Staff Passport to issue you a verifiable credential out to your own wallet, how we can use the OIDC bridge to integrate with wallet providers and provide claims back to a relying party. I've shown the management portal that can be used for a relying party to register and configure the requests that they want to make, and I've also shown you through our sample relying party that we've provided. I hope these tools will be as useful in your hacking efforts as they are in our products. If you want any more information about these, feel free to reach out either in River or directly to Condatis. Thanks for your time again today. Happy hacking.